Hello, this is my mega favorite numbers video. I was first deciding between numbers like Graham's number, Tree 3, and Ryu, but then I decided to go with something a little less known for just their magnitude. So I wanted to talk about Mersenne primes, but a specific Mersenne prime called the Catalan Mersenne prime. Since you clicked on this video, you probably already know about the formula 2 to the p minus 1. Now there are numbers called Catalan numbers, which are based on partitions of n sets. This is slightly different than having both a Catalan number and a Mersenne number. So the formula for a Catalan Mersenne number goes off an iteration of the Mersenne number. So you start with the same, except it's Cn plus 1 equals 2 to the Cn minus 1. So the initial value of this formula, C0, is equal to 2. To calculate C1, we take 2 to the power of C0 minus 1, so 2 to the 2 power is 3. We can continue this to get C2, which is 7, C3, which is 127, and C4, which is 2 to the power of 127 minus 1. Now this number, 2 to the 127 minus 1, was the biggest prime number in 1865, and it currently holds the world record for the largest prime number found by human hand. Now, so from comparison, this number, if you had that many E. coli, you would have enough volume to fill up the Earth. Now, if you guys notice, these numbers start to grow very quickly. Now we think about C5, volume comparisons really wouldn't help very much. So one thing we can say is we can talk about the current largest known prime number, which is 2 to the 825,899,33 minus 1. This took approximately 12 days to confirm. Using this approximation, it would took 26.5 decillion years to calculate C5. Of course, a good thing to point out is with more new technology, this should go faster, but that's just C5. Eventually you would have C6 and C7. Of course, once one of these numbers in the sequence is composite, all of the rest will. But really the important part is to prove that if the sequence terminates at some point to composite numbers, or if the sequence is always prime, it would take lots of clever proving on the part of other mathematicians. Now, this is actually very similar to Mills' constant, but just a little bit altered. Alright, I hope you enjoyed this video. Signing off.